Yes. Okay, now it's recording.
Okay.
All right. So,
Quiz. Oh, okay.
okay. I can go first this time if y'all want to the first question.
Sounds good.
Okay.
Sounds good. We get the second one.
Third one.
All right. Can y'all see my screen?
Yeah, I
Yes.
can.
So let's see.
Cool, cool, cool. Okay. Okay.
So it doesn't even take a list. I guess you have to create it initially, or
Yeah, I guess.
so. Okay, interesting.
Returns a list. That means we have to use cons. Is that right?
Okay.
No, it could just be. I don't.
Well, no, since you're
Let's just
just
get
making
started.
one list and you're not appending other lists, you could probably just create a literal list
Hmm.
first, and then just keep, um, I guess, appending to it. I guess you could do cons.
Yeah.
Yeah, that'd
Yeah, I
be
guess.
fine.
Okay. So let's make her. Is that how you do arguments for functions? I can't
That's
remember.
right. Yeah, that's
Okay.
right.
I remember.
And just an if statement.
We could do let's do null question mark, get the predicate or whatever they call it. So that will be our base case. Like if or no, just no, because we're not uh,
It's
conversion.
just I think
Oh, n
just
zero maybe.
zero. Yeah, just
Yeah.
zero. Like n equals zero.
So would that be n equal question mark zero or something like that, or that's the syntax for that? I don't remember. I feel like it's question mark equal, right? Yeah,
Okay.
base and then zero. Yeah.
And if that happens, it just returns an empty list. Okay, perfect.
And then you can just say like else, I guess.
I don't think for an if statement, there's just four arguments after it. So there's not like a closing parentheses. Does that make sense? It's a little confusing.
Okay.
Yeah, yeah. Then the else is
Okay.
just like there, I
Oh, okay,
believe.
that's implied else. I see. Okay.
Yeah.
So
Then
false
else,
then do
would we
list
just
maker
do
one.
list maker n minus one?
And no, we have to
Let's return
con it.
something.
Hmm. So do we need else there, or can we just like
It's implied. It's just implied that
okay.
it's else there.
Um okay. How do we do what's the syntax for that?
For cons, I think it's just like you have like a value and then a list, and then it adds the value to the beginning of the list, I believe.
Okay. So okay. So I guess we'll do so if we start at zero and keep going. Okay.
if we're starting at 0, wouldn't, but our base case is 0 already, right? So are we going in decreasing or increasing order when we're, so should that be n then, I guess?
Well, okay, so cons adds to like the front of the list, right? So we'll want to do like n and then, or n minus one, then n minus two.
That would
Like,
be decreasing order, right?
mm-hmm.
So maybe our base
Oh,
case
so
is
with cons, it just takes two elements that are not lists and combines them into a list. If that makes sense.
so it creates a
So
brand new list every time we invoke cons then.
yeah, and but you don't pass in any list to cons.
Oh,
If that makes
Okay.
sense. I think we might have to do append.
Yeah. Okay.
otherwise we're just going to keep creating new lists and then it gets ugly.
Well, it's
Yeah.
like the last one returns an empty list, and we append that to the beginning.
Okay, I see.
I think we would do like append and then no, append, then list maker n minus one, and then n, number we're on.
So you're appending, you have your whatever value is just returned. Okay, I see.
Which
And
would
so that's how you
decrease
get
for each one.
right. And since you're appending, that puts it in the right order.
Okay.
We
Okay.
can just test and see how it works, I guess.
Are all these parentheses lined up? Let's see.
Oh, I mean, that would still be decreasing order, though. I don't know if they care about that
Hmm.
because you're continuously adding a smaller value at the end. I mean, it doesn't say, it just says as long as it has a value ranging from 0 to, oh, that kind of implies order, though.
Oh, wait. I didn't have any function calls. Okay. Uh,
Oh, so n minus one also won't work. It'll have to be the parentheses, the stupid parentheses thing. If that makes
Oh,
sense.
right.
Like parentheses minus, yeah.
oh,
Minus n,
right.
right?
Yes.
Scheme moment.
Okay. I think I'm missing a parentheses from the if statement, right?
Uh, yeah, okay, I see now. Yeah.
That looks weird. Okay.
Here we go. Just expected append 1, 3. Okay, so append, I guess, expects a list at first. Could you do like just, can you put like a literal behind it, like a little apostrophe? Maybe it'll be fine with that. Because that would convert whatever it is into a list and it'll just functionally work. Oh no, I meant before n minus 1. Yeah, that parentheses. It's a duct tape solution, but it might work.
Okay.
Good stuff. I guess it never terminates.
uh,
Oh no. No.
Oh god.
Interrupted. Okay.
okay. Timed out, I guess. Um, okay, so I think it's like the like this argument. It's not like creating a list ever. So we're like appending to like nothing.
I mean, we technically make a list with the apostrophe part, so I don't know if that's it, right? I mean, the apostrophe n minus 1 just takes whatever n is, subtracts it, and then it makes a list just populated by whatever n minus 1 is. So if we kind of trace it to the first call, say it's 5, okay, that's not equal to 0, so then we go to append. So then we append to a brand new literal list that we make, which is now 4. And then, wait, what happens to n? what does append do to like A and B? Does it append A to B? For example, does it append n-1 to n or n
Append just takes two lists and joins them together into one.
two
Okay.
lists?
So
Okay.
then
Yeah.
this n is not a list.
Oh.
Okay. So should we should we append I'm not sure we should append n-1 to n because in the example it gives us, it's like the range is from 0 to n-1. So if n is
Yeah.
5, it should end at 4, right? So what if we just like appended it to an empty list?
Okay.
Oh, yeah.
Let me think. You're appending. That would still be decreasing order, though, I think. Um, although you're right, it wouldn't start at 5 because I think the way we had it would be like 5, 4, 3, 2, 1 or whatever. I guess that'd be 4. But still decreasing order. Yeah, whatever.
Let's see. Okay.
All right, we gotta figure this part out. This death loop. Is it because hold on. Append list maker. It almost feels like it'd be ideal if like we could start where it's equal to 0, then create the
Mm,
list, and go back and push these values. That would be nicest.
yeah.
But I don't know how to recursively do that. Not in this language. Okay, let me pull up some functions to look at that he
Oh,
provided.
I got it to work.
Oh,
What you got?
perfect.
What I got? Okay, so let me compare what I got with what you got. So I got the so just on the else, I did append list maker n-1, yeah. And then for the and then in list maker, I just passed in n-1, not as a list.
Okay.
Yeah, just like that. And then for the second part, I did um I made a list of n-1. And you used the word list because the apostrophe wasn't working for me.
Okay.
Interesting.
I don't know.
Wait, so you're adding? Oh, right, because the n-1 call, it's that's not an actual value. That's the recursion. So it's fine if we make a list of n-1 because that's not represented by the
Mhm.
parameter.
Do
I
you need a
guess
parentheses in front of this list or
In
is
front, yeah, around
it?
that whole thing.
the function, yeah.
And then a space between. Yeah, you got it.
Cool.
And hopefully that works.
All right, cool, cool.
Nice.
Perfect, perfect, perfect. All right. Let me pull up Zoom. Nope. How do I? Can't find the. Oh, there
Okay,
it is. Okay.
let me pull the quiz real quick. Actually, you can just watch on yours because only one person submits the quiz, right?
Hmm.
All right, let me find Zoom here. Okay, can you real quick share your screen just for the question? Because I don't know, do we all open it? Last time did you guys all open the assignment even though you
Yeah,
didn't? Oh, okay, you can
I
just
opened it and still got the grade later on.
oh,
So
okay, cool. Let me open it then real quick. Take the quiz. Okay. All right, I'm sharing my screen. Create the function triple everything. It takes a list of integers identified by sequence and generates a copy of the list Okay, takes a list, copies it, and just triples everything in it, I guess. Okay. Weren't there provided functions that he gave us that were something like this, where it's like double everything or something like that?
Remember, was it like a lambda function? Does that ring
Oh,
a
and
bell?
it does ring a bell, not very well. I remember reading about those.
Ooh.
I don't remember much about them. All right, let's see then.
It's a filter. A filter function?
Yeah, filter function. Right, right.
Wait, no.
Wasn't
Filter just
filter like not in Gambit though?
oh, it is. Maybe. I would be surprised. I think oh, we use a map. Okay. The function's called map.
Map. Let me
It's
see what
at like the
mapping.
very bottom.
Oh, okay, see, maps apply a given rule to a function. Okay. So let me just real quick read through the example he's got here. Okay, so define.
So we define our function. Oh wait, no. Yes?
Define map car function list. Wait, why is there in okay, so for an example I'm screen sharing right here on the notes, why is it that okay, so we have define map car and then it says func list? What's the function tag for?
You just pass in two things. So the function is the one you want to pass in. Sorry, that doesn't make sense. But like the example it gives, you pass in a double function.
Okay.
So do we
Oh, okay.
make two functions? I think you could just use a lambda
How would I use
because
a
all you pass into it is an integer. Is a list.
mhm. Right. And the function itself is pretty simple where you just triple everything. So I don't know if we need to inherit another one. Oh, we can just do that in-house. Oh man, what was that?
Because it might only want one function. Is there an example with lambda? Oh gosh.
Maybe.
Map double. Because in the example he had, oh, wait. In the example he had, oh, this is confusing now. I think we're overthinking this. I think we just have to go through and make a list that you double everything.
Yeah, maybe. That feels oh, okay, missing the starting parentheses. That's what it was. So this feels wrong. Okay, so if we have our base case, we just return a null or an empty list. If not, then passing in the function, uh, we have to define that separately though, right? Where we triple a list, or no, you're saying that we don't even need to inherit a function. We can probably just do it by hand.
Yeah, I think we just do recursively. It goes through and
Okay.
each time it just passes out a list, obviously. Um,
So then that would be, let me think, list. Oh. Would we want to add, or would we just want to retrieve the element, triple it, and then push back in? What do you like?
I think we might have to do like car and cooter things.
Mhm.
Right, yeah. Okay. Okay, so we get the
Exciting.
first element. Oh, okay. I gotta remember the syntax, but yeah, I know what you're talking about. Function parallels.
There should be examples, I think.
Yeah, I remember looking at one. I'm just trying to find it. The computation is +1. blanking on the actual syntax. Is it car parentheses list? Where is it? Okay. The syntax is probably wrong, but what I'm trying to do here is do like the times car list and then 3. And then after that, well, we need to, does car list actually like destroy that element list? Does it retrieve it and then break it,
I
or
think
does
it
it?
just gets the first value. That's
Mhm.
it.
Okay, and I remember seeing something about aren't elements in a list immutable? Like you can't screw them.
I think whenever you do like the CDR, it just returns a new list.
Oh, okay, gotcha. Everything. Okay, so I've multiplied the first element by 3, and then I know how to access this. And then how would I merge these two? Would this be a con or just it doesn't matter? So if it's null, just return an empty list. If not, then multiply the first element by 3, and then what am I missing between these two? Because we're not adding it,
I
right?
think I think there's a parentheses around cooter in the list.
Oh, is that sufficient, you think?
Um, guess we'll
Multiply.
see in a sec.
When you were unable to do GSI last week, what did you do? Did you just go into the other server?
Yeah, I just went to the this one where you put the compute server. Yeah,
Oh, the
that one.
compute server. Uh, ill film, okay, ill form, special form, define. Oh, wait, no, am I missing a parentheses or something? So define triple everything.
Did you have to cons the list together at the end, or cons the new value
Oh, like
and
right
the
here.
list of returns?
Are you saying right here?
Yeah, but cons goes inside the parentheses.
Sorry, oh, yeah. I know. Incomplete
I
form
think
and
you put an extra parenthesis somewhere after cons. I think there's only one there.
you think, no, that one's still around everything though, right?
Well, we want those to be passed into cons.
So this one?
Yeah, yeah.
See if everything matches still. Oh, okay. I see what you're talking about now.
Yeah. Define what?
Full form special term. What?
Oh,
A white space or something? Or
there needs to be a parentheses around the function name and the things
oh
you
my.
pass in. And you also don't type the inputs.
Wait, what do you mean? Like list?
So after true up everything, it would just be a space and then L1, and that's it.
Oh, you don't need to declare data type or something?
Yeah, in schemes, you don't need to type them. And there wouldn't be parentheses around it either.
Right, because it's just a literal, it's not a function. Oh my god. Wrong language.
You use Vims or Vim.
I do, yeah. I use it at work a lot, so
Okay.
operator is not a procedure. Okay, it didn't triple correctly, but it did return a list. It says that line 10 operator is not a procedure, so my multiplication is bad.
I think it's at line 10. Oh, you put two parentheses around the triple everything call. Oh, dude, you're in the wrong language again. Oh my gosh.
Help me.
You
Oh,
just put a space after triple everything and then the input.
okay, so triple everything. I don't need this parentheses because we're okay.
But because it's a list, you.
I need the parentheses around the list though. I see.
Oh, but you're also calling list like a function in another language. List also goes inside the parenthesis with the other elements.
This is torture. Uh,
Like inside the parentheses before the one.
okay. Wait, like that's space? That's
Yeah,
a
that's it.
declaration.
That's perfect. Yeah.
So weird.
I know, it's throwing me off so bad. Pair expected car procedure. Line 4, it says. Pair expected. That's weird.
They're expected.
So I'm saying car list, multiply that by 3, and then
One thing I'm
cons.
seeing is that you also need the parentheses around display at the end.
Take this keyboard away from me. Okay. Is there anything else here? The list cons. That cons syntax looks good though, right? Because cons is a function, so we need the parentheses. And then star is an operation, so we need the parentheses. Car list also same thing.
Yeah.
Uh,
Times 3 and I
this
think it
looks,
looks good.
yeah. Oh,
Pair expected.
okay, on column 12 it says.
Car list. Oh, it's because the list is L1. The name of the list is L1, not
Right.
list.
Oh, okay.
And for the
Good.
null condition as well.
Yeah, that makes sense. Okay, that looks good. 3, 6, 9,
Did it work?
12. Yes, that looks right.
Okay.
Cool.
Sweet.
Cool, cool, cool.
Okay. Let me do this now. That is not what I want. Okay, let me share it first. I forgot about that. Okay. Oh god.
Create 2 functions.
Min list.
We have min and max lists that he provided. I know that those are filters that we've been given.
Min max list value. Space both the lists together. It should. I'll put 1 4. You cannot use pre-built min and max.
Oh no. No. That's terrible.
Okay, so we go through and find them and then just combine them.
Man,
Save them
that's
for me.
okay.
I think they'd be very similar, so it isn't too
Mhm.
bad. I don't know what to do. Was there an example like this?
I don't remember there being an example like this, but
It had
um
examples of like just finding a value in a list. So
Mm-hmm.
it can't be
mm,
like too different from that. You just,
you have to
compare
define
it.
some kind of integer outside all the functions to keep track of your min max and then pass it in as a parameter. Does it say what we can and can't have as parameters?
I think, oh, okay. Wait. I have an idea now. You you go in, obviously do the check if it's empty, whatever, and then you pass in takes a simple list number as a parameter, turns in a list. Oh, dang it. I was thinking about passing that number into the function and then it can check.
Yeah.
Oh no. Okay, wait. Oh, okay. No, this is really confusing. Let me see if I can.
What if we
If
just
no
grabbed,
list?
what if we did like C8 DDR and just kept, do I have this?
Okay, this is gonna be a little crazy now. Wait. Never mind, I don't have an idea.
On page 19,
Page 19.
they use recursion to find an item in a list.
Okay.
And it looks like they check if it's null for the base case. And then he's comparing it if it's like equal to a value that gets passed in. But you could compare it to like the car of the list, whether it's greater or less than.
Mhm.
Mm-hmm.
If it is less than, then it like takes the place.
Oh, okay, and then you do a call using that one.
Mm-hmm.
So would you be storing it within the list or is it a separate value that gets,
Yeah, how would you?
because maybe what you could do is if we have access to the superset of the list, we could just keep overriding the first value because that's our initial comparison. So we've already gotten our comparison out of it. So we can just start like, the idea would be at index 0, no matter what, that'll be our value of interest. We can just keep overriding the first index of that list. And that way that'll also handle if it's just a one element list. So I guess you could do, and this is still a size scheme because I suck at the syntax, but you first check the first element. Um, and then you could do like a CDR to get the next one, do the comparison. So it's everything is in reference to that first element of whatever list you're passing in. And as you iterate,
The next time you just pass in a smaller list.
yeah,
So
and you know that no matter what, the first index of that list is your current best. That's your current biggest or smallest, depending on the function. So that's a way we can store it without having to make another integer. Does that kind of make sense? So we keep making a smaller list, but we no matter what, our first one is our, because we can at any given list, we can compare the first and the second element with a guarantee of, okay, those should exist. Well, they're not a guarantee, but because we can't make another variable, right? I mean, they have examples of calling it. Maybe like do the less than operator and then maybe like car list and then CADR list so that you can get the atom of the next element
mm-hmm.
and you can just do a less than. And I feel like if it doesn't exist, then it'll throw some kind of error or it'll just say, well, this isn't less than it. You can't be less than nothing. It depends on how scheme interprets it there. But might need another case where we need to assume we might need another base case where do we have two elements? So we check one, hey, are we empty? Just for the sake of doing that, we can have one where, hey, do we just have one element? That actually might be better than just empty. Does this kind of make sense what I'm saying?
I think so.
So like it's the first element, and then do a CADR list.
CADR?
Yeah, because we want to skip to the next one because we have to do a comparison, right? If we're getting a minimum.
Well, what if the list is empty after that? Is that okay?
That's what I was saying. I don't know if that can be. We might have to change our base case to not be if it's null, but if it's say
It just
length.
returns. Well, you can't return a value
Mm,
because you don't know what the minimum, right?
yeah.
Um,
Although actually not necessarily because if we had a point where we have a list of one element, we can say safely that the minimum value in that element is itself because it has no one to compete with.
Well, then we should like think of what should happen in that case. If there's only one thing, we pass it in. It's not an empty list.
Mhm.
Okay. We then car that list, get that value, and then
And then after that,
I
we've
think we
gotten
might just have to pass the CDR back into the function.
that's the CDR function. Like
So
talking about the except for the base case right now.
yeah,
So wait, where are you going to CDR the rest of the function? Are you talking about this base case that we're talking about, or do you mean just in the general recursive call?
I just don't know what are we comparing this less than. Car list is less than
We
just
actually,
say
yeah. Why don't we just do CDR list actually? Or that's where we do our recursion, maybe?
because this function does return a value.
Uh-huh.
I should it's not
Let's see here.
and then what if that's it?
I
No,
was
that can't
gonna say,
be.
yeah, that might be sufficient.
And then this returns car
Um,
list.
y yes, if that's true, because then you're saying if
Mhm.
Carlos is less than, wait, what if it's less than or equal to, and we're at the end of our rope?
Then
Should we make it less than or equal just to be safe in our operator? Because I mean, if it's less than or
oh
equal, minimum.
yeah. Is it okay to write that? Can you write that?
Yeah,
Is that
I'll
legal?
check the notes and make sure that's the syntax.
Else.
Are we able to compare like the car of the list to the CDR of the list? Because like if it's like four elements, right? And we compare like the first one, like are we able to compare it to like
That's
a
where
Here we go.
I think that's where we're not actually going to be doing the comparison until the recursion is finished, and then it steps back down the value stack and actually
okay.
talks the number.
I forgot, like it wouldn't be CD, it would be I have to do this now. I forgot to call the function. There we go.
Yeah,
Okay. Okay.
And
yeah.
now do these parentheses match this one, this one, this one, and then it returns. This is equal turns car list. Otherwise, it returns if it's greater, we call the function with CADR.
Yeah.
Yeah.
So we have another recursive call. If value. Actually, I don't know if we should do that because it's not like we're only doing recursion in the first case if a certain case is true. By definition of that if check, we guarantee that we'll recurse down to the base case. So if we're
Mhm.
if we're going back down the value stack and we say, okay, well, 4 is not less than 2, if we do another recursive call, then we're going back up the value stack, right? And we're going to be there forever. So do we need an else?
Let me just like okay.
Yeah, maybe we can get a shot on it.
I was gonna like yeah.
Let's do it.
Is this am I writing?
Don't think oh, they were not lying. This lab is different than the last one.
Yeah.
We got a parenthesis somewhere. There needs to be one right here. Oh, another one?
What?
line 12. Okay, this looks good. This doesn't look good.
Mm.
Define
Special
line
function.
9. 1, 2, 3.
Oh,
Did I do some?
nothing happens in it. Do you want maybe just comment this out for now?
Oh yeah,
We haven't written anything to it.
doesn't return anything. Real expected. It checked it with the list. Okay.
Maybe instead of returning the an empty list, it should just no, because we can't read it through that.
If it's empty, don't return anything? No.
No, but I feel like what happens is so right now we're returning a list type, and then we keep comparing scalars to lists. So it would be ideal if our base case somehow returned a scalar. I don't want to say 0 because then that muddies the waters.
What if we just don't even use this? What if we just this might be a stupid idea.
Yeah, you know what?
But
Go for it. Let's do it. Dang.
pair expected car list. Oh god.
Here's a comical idea. Or actually, no, I don't know if we can do that because now we've destroyed our list. I was going to say, why don't we just return some arbitrary value in the list? I mean, sure, it'll duplicate, but it won't change what the min and max is because it's a duplicate. It already exists in the list. But I don't. I mean, at this point, the list is dead. That's why that's what we're checking.
I wonder
is list
it
null
must,
even?
it, it's
Maybe that's not.
because it shouldn't. You're right. What if we just do this? Is that allowed?
It doesn't return anything. I feel like it's gonna cry at you and be like, "Oh, we expected something. We wanted a return."
Real expected true? What?
Oh, okay. So I guess like the base, if you don't return something specific, like
Oh,
the
It'll just say,
default
"Oh, we did."
return of a query is just like
is there
bool.
like a maximum value in scheme?
I was just thinking that, yeah, is there a max? I wish I could look it up or something, but I haven't. He hasn't talked about it. I was thinking, I'm like, dude, like N32 max would be real great right now, but we can't guarantee. Mm.
So
Oh, I noticed.
why is it saying true if it's null? Because the list that we're passing in is not null.
I think it's because we keep cutting off a part of the list until it does return null, and then since we aren't returning anything, the scheme compiler just says, "Hey, you did hit this condition," so it just returns true as in it did happen.
Okay.
Yeah, you can make it something absurdly large for the sake of the
In
lab.
this case, let me just put like 6 because that's bigger than anything that
Sure.
we're testing. So let's just see if it works. Car 3. Oh god. Car 3? Why did it do car 3?
Where is car 3 happening? Wait, what?
It must be on the second one. We pass in CDR of list.
Should
That's how CDR works, right?
CDR cuts out it returns a list. Is it crying that we're trying to compare a scalar to a list? Is that what it's moaning about? Because this is
If the first value
should we
is
wait,
less than the minimum value of the rest of the list,
should
return that
we,
value.
should we try and do car list compared against CADR list again? And then just do a recursive call.
Oh, it's right here. I think
Else min value.
this should be CDR as well. Because our function takes a
Oh,
list.
yeah, because that makes much more sense.
1.
Hey, there we go.
Right.
That is promising.
You can put negative numbers, right?
I think so. Hey, all right.
Awesome.
Let's go. Yep.
Wait.
No, that's right.
Oh,
That's
I put
right.
-6. They put a bigger number there just to check. We can move on.
That's
The next one should be the same thing.
Yeah, let's just make sure we go back and change that 6 placeholder to like 99999 or something.
Let me just see what happens if I put. What happens if I do this? It does. Okay.
Yeah.
I don't like that
Yeah,
at
I don't like
all.
the 999 solution, but I can't think of an absolute max constant because
What if we just
playing with fire.
define? Oh, let me just see if
Oh,
this works.
but those would be convenient.
No,
Expected.
no, there needs to be some case when the list is empty. It does.
What happens if it just returns true? Let's just like honestly go back to your idea earlier and just cut out the -20. Let's just see. Yeah, returns true. Who cares? It's not going to
Yeah,
be.
it it might care a little bit. What did they do in these other nodes? How?
I will say though, while it did print out true, it still did give us the negative. Oh no, it's a -16. You have -16 there. Never mind. We might want to just put a pin in it, put like 999 or something, and then complete the rest of the lab just in case.
Okay. Do you want to search and see if there's like a max Lyman scheme? Whatever we're
Just
using.
What was that? Sorry, I didn't hear
Find
you.
if there's a max value in scheme.
yeah, like like a int32 max or something like from C or C++, just like a ceiling that we can rely on. Which time do we have in this lab?
I'm looking at the documentation. I'm not seeing anything about uh like any kind of max, like integer cap or anything.
We might just have to be
Hmm.
pragmatic, just say 9999 or something, something absurd.
Yeah, okay, that one worked as well.
Awesome.
So then make another function. Okay. What's it called? Min max. Max list value. List. This seems really easy. Is it just append? Then there's the two functions?
I would imagine so. What are we?
Yeah.
Another function. Hmm. Yeah, that seems like it would be just a combination of your previous work. I mean, it just outputs a pair, right? Yeah.
Oh wait. I, I know there's a typo somewhere. That I hope it works. Let's see. This I don't understand why this happens.
Oh, the literal is giving you trouble.
Yeah, I think I might have to do this.
If it works.
It didn't work. They don't work for me.
Yeah,
I don't
just do the
understand.
list, whatever. Wait, does the parentheses, since it's the apostrophe, since it is a function, does that have to be surrounded by parentheses, you think? Or it's parentheses, apostrophe, and then
Well, I know that apostrophe also turns things into strings. Instead of like putting quotations around things, you can just put an apostrophe at the beginning.
oh
It
yeah.
might be a backtick, but I don't. This works for me. I'm happy
That's
with
okay.
this.
Yeah, I like list better with you.
Real expected. Okay. So in this one, 999. Oh, interesting. Line. What did it do? Did I mess up parentheses? Oh, I didn't put.
Yeah, getting past it.
Didn't work again.
Hmm.
Line 18.
Line
Turns this to a list. Is it because I don't have enough parentheses or something?
I don't know. Maybe we should just try and display each one first, and then we can just try and merge them in a list.
Well, that's what we already did. We already just. You mean within this function?
Yeah, just because it looked like it just spat out like the entire superset, right? Instead of just two values like we expected. So I just want to make sure that something's not wrong. Because okay, append.
Just try this again.
That's
Operator
weird.
is not a procedure. I think.
It doesn't like append for these. Wait, wait, hold on. Does append work
Oh,
with scalars?
I think it's because list is a.
Reserved
We
word?
shouldn't use list as a parameter, an argument,
Mhm.
because it then we're calling it as a function here, but then it's a parameter here, and it doesn't understand that.
Mhm. That might be a
There we
yeah.
go.
Okay.
Nice. Good stuff.
Perfect.
Okay. Just what do we want to do about
Yeah,
because
the extremist.
I'm sure they're gonna test like the maximum values.
Maybe. Yeah.
Is there
Um,
anything else we can do? I don't.
what I would like to do is just instead of creating a min or max, in 32 min or max, is just literally duplicate something from the list because then you haven't contaminated the min max content, uh, but you still have a frame of reference to start, with your base case. It's just upon that point we received a destroyed list. The only thing I could think of might be over engineering is genuinely move the base case to we're about to be a null list, but we're not, where it's one element.
That's what I was just thinking. If cooter of list,
Mm-hmm.
what do we?
Carve list.
You just
Yeah,
don't.
carve
Maybe
list.
in this case we call this if else again, but without.
Could be. I'm thinking though, it wouldn't hurt to just no matter what it is, if it's the min, the max, or in the middle, you just return it because then as it goes back down the value stack, it'll keep comparing that duplicated value. And since we have a less than or equal thing, that's not going to brick it. Um, Even if it's got a middling value, as it goes back down the value stack, it's going to then check against every single other value that we've gotten in the list recursively.
Right. So what were you saying that I should do?
I think car list. You're just
Car
returning
list.
whatever it is. Yeah. Like we're basically saying we have one thing left, just return whatever it is, and then we'll do all our comparisons here.
Oh, that makes a lot of sense. Okay.
Because since it's an element, an existing member of the list, it doesn't contaminate our results. It just duplicates it, which who cares? We're not measuring length. So we'll see. All right, cool.
It worked. Yeah, unless you want
Awesome.
to throw any. This looks like a pretty good test of values. So I think I'm happy with that.
Like, yeah, honestly, that is very sound.
Okay.
Cool.
Should I get rid of the display in this one? Does this matter? Maybe not. I think it was fine in the other lab.
Yeah, we got
Okay.
100. That's fine. We
Oh,
have
it
check.
needs examples. Okay. We want
Oh,
two examples with two different results of each function.
cool.
What?
Come up with two lists. I guess two different results just means you should have a different min max pair.
Oh, okay. Yeah,
That's
I'm
pretty
being
trivial.
stupid. Okay. Looks great to me.
Mhm.
Looks kind of ugly, but Looks perfect.
Yep.
Maybe I should
Handle large
add a new
values.
line.
Cool.
Okay,
You.
are you happy with this one?
Oh yeah,
Yeah,
absolutely. Yeah, this is
Okay,
looks
perfect.
good.
I'll
all
stop
right.
sharing then.
Awesome. Nice stuff.
Okay. Also, it looks like we might be running a little bit lower on time for this lab. So if
How
y'all
much?
want to like email me, I can put it in the chat. Your files like now, so I can just like upload them as we go.
Sure.
Okay,
How much time do we have?
we
I
have
think
34
about
minutes.
yeah,
I have 30 minutes.
Okay. I don't have my SCP running on my Mac, so I have to log into my Windows and do one SCP for that. Give me a minute.
all right, cool. Right.
A union that returns the union of two symbols and sets if you're going to duplicate.
Isn't this just oh, so it's a pen, but you have to remove if it's like in both lists, you remove one of them.
Mhm.
Okay.
Does it say anything about not using built-ins
Um, let me
other than the remove duplicate? I can see it doesn't want me. Yeah. But are we allowed to use stuff like find or search? Because I think those exist, right? That would be really helpful. And
it doesn't look like it says oh no, okay.
you can't use, yeah, that makes sense. How are we gonna, for each value, how would we check?
I remember there's an example he gave of combining, like making your own append function, and it like went through values of the different lists.
Mhm.
I mean, I guess, oh, there's like examples of finding an item in a list, and so we just have to do that for every value in the first list.
Okay, I like that.
And then that returns, or that statement we have just returns true or false. Do we have to do,
If it do the find and if it returns false, then you can append, otherwise recursively call for the next. So I think that we'd have to, or no, because in Gambit we can't pass in a function, right? We can't do that. So I guess we'd have to just straight up invoke it. So I think the plan is like you were just saying, you write the find function that we've kind of been given, sort of so to speak, in the notes, and then just invoke it during our recursive call, like our condition.
yeah,
Is that what you're saying?
I'm trying to think now.
So yeah, we can say if null L1, um, just return an empty list for now, because that's pretty safe. And then we can come back and see if there's anything fancy we want to do. We'll keep that in our mind.
So we're like car and or like car and CDRing through the first list and comparing it to every value in the second list, kind of.
Yeah, that would be offloaded to the find function though. So maybe we have a choice. We could either write the find function right now and worry about that, or we could write this assuming we have the find function work and then do it after. I don't care.
Either one's all good.
I don't know if we're
Write
allowed
the
to use
find.
two functions though.
Really? Right.
It says just write the function union.
Mm.
Okay, so do all the work. Then we might just have to be smart about this.
Oh no, I hate doing that.
Yeah, I know. Like you just car the value of the first list and then check it in the second list.
Okay. How would you check it with the
Oh,
I guess you could do like the um,
Where is no origin? Sorry, I'm trying to get my file over to you right now. Such a pain. There we go. RL1. Yeah. Okay, so now you're checking if these two elements are equal. Actually, I swear there is some built-in thing where you can do equal for just the list, right? So maybe that would be part of our base case. If they're equal, it's null.
um, okay, so if we like construct a list with all of L1 and then use like car and CDR to go through the second list, we can I don't know. I don't know if we should compare like every element with each other or if we
Yeah,
can
because
like a,
I was thinking element wise comparison too, but we can't assume that they're in order or that they have the same number of elements, right? Didn't say anything about that.
yeah.
Uh, I like the idea of making a third list and just turning it. Um, this one's hard. This would be a lot easier if we could have a helper function. Okay, so at this point we've said, are these two elements equal? And if they are, then what? Do we
So if they are, we can add like car of L1 or like just like one of them to like a third list. And if they're not, we just add both of them.
yeah. What if would there be some way that because I remember Oliver, you said something earlier about you hold one list, like you don't destroy one list, but the other one you continuously traverse and compare to all the other elements, right? So
Mhm.
like we could probably do that, like kind of in the notes that you have pulled up here. Because what does he do here? Okay, so he says from step number one, you have these two lists and you pop off X, Y, Z, etc. Print append. No. Wouldn't it
Oh,
just be
okay.
this with
So if you don't change L1 and then you just compare, so let's say you have like the full L1 list and you compare the first element of L2 to every element in L1. And if it's not in any of them, you can just like append it to L1 and then do the second element. And that takes care of any repetition between the lists and also repetition in L2. The only thing it doesn't do is if there's like repeats in L1. But I don't know if the
well,
question.
well, part of your logic there is that you're checking for repeats in L2, right?
Mhm.
So if in L1, let's say
Yeah.
same number appears twice in L1, If it whether it gets pushed or not to L2, you're going to continuously compare, hey, does L2 already have this? So it doesn't really matter if L1 has repeats because L1's getting it's getting mutated anyways. It's not the return, right? That's not the
Oh, okay. I have an idea now. Wait. Okay. My idea is that we create the first part of the function just checks if the length of the first list is greater than 1, then call the function with the first list, removing the first value. And then finally, now on a different one, if it is 1, then we can go, never mind. That's not going to work. Let me think about that one before more.
yeah. I like where you're going now.
Me too. Me too, man.
This is rough. Uh, let's I mean something's better than nothing. Oliver, let's just full send on the idea you're talking about here, your logic, if you know how to put that in syntax.
Right.
And it probably won't be perfect, won't have repetition, but we gotta get something on the board.
Okay. Um, hmm. How would we format that? So we're comparing like the car of L2 to every element in L1, right? So okay.
So perhaps it would be car L2 equal and then you can recursively call the function name with CADR, right? Because you don't want to compare the list, you want to compare. You've got your first element, you want to move over one, grab that element, and then recursively pass that in. So that in each recursion, or no, it wouldn't be catter, it would just be CDR, right? Because when you go back on the value stack, that would become a scalar. So do
Mhm.
question or equal question mark, and then do car L1, and then the second one would just the recursive call for CDR L2 or whichever one, the different lists. CDR the one that you don't want to return. And then what that does is that it goes element wise through one list and checks everything to the other. And then
Mhm.
this isn't efficient or elegant, but then we can have a second line in this where we do the same thing for the other guy, where the other guy now becomes the point of reference and vice versa. Because whenever we CDR, we don't actually destroy the list, we just examine it, right? So
Mhm.
we can still go back and do it again. And that way we can make sure that we didn't miss any values. If there's different lengths, we can still account for that. So it's going to be ugly and not terribly elegant, but it might just work. So yeah, equation car L1, union CDR L2. Okay, and that ends the equal. If equal, now what happens if it's true? Okay, if it's true, we don't really want to do anything, do we? Because that's saying, okay, we found a mismatch. Now, if it's true, do we do anything if it's true, or do we just care if it's false? Because if it's false, then we would push, right?
Yeah. Well, if it's true, we want to like get rid of one of them, right?
I don't know if we can remove it.
Or
Well, the
just
question is,
not add it to, just not add it. Maybe not remove because we're like keeping one as like our return list, right? Then the other one we're just kind of messing with.
yeah.
So if it's true, if they equal at some point, we just don't want to add it into the list that already has into our like return list.
So my question is the return list a brand new one that we've defined, or are we hijacking L1 or L2? Because I think either is valid. We just have to decide.
Yeah. And maybe
I think maybe we make a new one, right? Because we return an empty list for our base case, which kind of creates our new one. So if we just continue to append,
okay.
I don't know, I'm just thinking out loud.
Yeah. Yeah, no, it's good. So okay, so if it's true, we want to.
How much time do we have, by the way? Not to rush. I just need to know if I need to send you my files right now.
We have 19 minutes. Oh man. Okay.
I mean, they expect that we don't finish some labs. That's why it's a question on the survey. I'm not worried about it. Let's just make sure it's done best we can. So, okay, anyways, we decide that we're making a third list. That'll be our return. So if it's true, that means that this exists in L1 and L2. Oh, if we're making a new list, then we have to see if we've already made it in L3. Because what if it's not ordered?
Hmm.
Um,
Well,
let's
if we've already added it to L3, right? So if we're comparing like every value in L2 to every value in L1, then it shouldn't, like if it repeats at all in either of the list, then it shouldn't get added. Yeah, or it should only get added like once.
I see. Yeah, okay. We can go, we can work on that assumption then. Worst case is we're slightly off and partial, whatever. We can work on that assumption. Okay.
Okay.
Yeah. So okay, we've said if they're equal, then true means that we would, I guess we can just say append. No, we wouldn't append, right? Because we're equal. We're like, wait, we hate this thing. We don't want this.
Yeah.
So,
Well, so we depend like one of them though, right?
oh yeah, you're right. Yeah, okay, sure. Just arbitrarily append car L1 then. Sure. Append car L1 to CDRL2.
What? So, okay.
Or will just be L2.
Wouldn't it be our like our new like our third
Oh, it
list?
would be. Yes, it would be.
Okay.
Wait, how would we
Hmm.
reference that though? Oh boy. So we made that new list.
Could we just like append it to an empty list? Is that like allowed? Is that cheating? I don't know.
No, I think that'd be fine. I just worry that like for every recursive call, we just create a bunch of isolated empty or populated lists, but they're not actually linked. So you
Yeah.
append or an empty list.
Can I def hmm.
Can't. We might need a con and just actually hijack L2 after all. That might just be simpler.
Yeah.
Okay, so or we could hijack L1 since that's the one we're holding constant. Okay, so right now, since we're CDRing through L2, we're checking everybody in L2 against just one value of L1. So it's probably safer. Yeah, add to L2 since L2 is constantly being examined. It's more likely to catch duplicates. So,
Okay.
I mean, what do you think? Does that make sense, I guess? Because L2 is constantly getting union recursively called, so we're always checking something on union. So
Yeah.
I don't know. I mean, you don't know. But
So yeah. Okay. Yeah, this is complicated. All right.
yeah. Brutal.
I think that is at least on the right track.
Mhm.
Okay. All right, let's just assume that's right for now. Um, so that's if they are equal.
Mhm.
Yes. Okay. Uh,
And if they're not, wait, wouldn't we do that no matter what though? Wait, if they're not equal, then we have two unique values. We can push them both.
yeah.
Oh, yeah, that works then.
Okay. Okay. So this is like the implied else statement, or like not
You can
else
just write it.
statement. Okay, so this doesn't need to be on a new line then.
No, I think that's yeah. You can keep it on the same line.
Okay. Okay, and then this is our new this is like our else, right?
I
False.
think so. Row one, row two, cons. Wait. Yes. Okay, whatever you put here, if I'm counting your parentheses right, this is your implied else. So then here you can say cons uh cons L2. Wait, no, that's
Wait, okay, so this statement up here should be our so if we're like hijacking like a list that we already have and we're just adding stuff to it, then this should be our like if it's true, right? Because then both values will be in our list.
right.
And if it's false, then we just don't add. We just don't add anything, right?
I guess so. So false is we might have gotten these backwards.
Yeah, okay. Yeah, I think we did.
I think we have backwards.
Okay.
What do you think, Andreas?
I was trying to figure out something. This is crazy.
Yeah, this is crazy hard.
Do y'all want to, let's see.
I need to send in my files actually. I'm gonna do that real quick. What were we saying?
Like at 10 minutes we try the next one instead. I don't know. What do y'all think?
I'm good with that. Yeah, we just get something,
Mhm.
non-zero. I'm good with that.
How much time do we have?
12.
So if it's so okay, so if this is true, if they are equivalent, then we just like don't want to add anything to our L2 that we're like mutating.
Yes. Yeah, since we're mutating L2, that means it already exists in L2. We don't need it.
Okay, so for our like return value, um, I don't know how to because it has to return something, right? Or can
Yeah,
we?
returns the list. So uh you can just have it
Just
return L2.
L2.
I don't know if that's valid, but I mean that's kind of what we set up for, right? Because L2 is like what we're pumping our results into.
Yeah, I
So
think so.
I
Yeah,
don't
so
even
that way we're
know.
just going through every. Okay, okay.
I'll come up with another test case real quick for this because I think we need two each, right?
Yeah. Uh, oh wait.
Man, it's a bad day. My file explorer is crashing. Like, come on.
I think you need one more parenthesis in the main definition,
Oh my God.
just at the end. Oh,
Okay. Yeah.
I think you might need another one after the end of the first display.
What? No. Why is it?
Yeah. And
But I
delete
still
one of
need
those,
proof
I
it.
think. Yeah. I think
Okay.
there should be two at the end, like another one.
Oh my gosh, what? Okay.
Yeah, yep, I agree with you. That's pain.
Oh,
Kicking my butt there too.
oh.
Just do a tab complete, do like scheme lab and then just tab.
Ill-formed. Uh-oh.
Did you put a parentheses around it? Or should we do a cond or something?
Oh, okay. I think it was parentheses. I think.
Everything's crashing right now. This is such bad timing. Oh my god.
All right.
Jeez.
On line 11.
What's our time like?
Delete one of those parentheses. Oh, wait. Oh, that worked. Never mind. Okay. Nice.
How's our time looking?
We have 8 minutes left.
All the time in the world.
Okay. Where is this ill-formed if?
So I think what's happening is that there's the condition and then the empty list. And then there's one parenthesis around the equation to the L2 in that line.
Mhm.
And then so then we pass in another condition which is on the next line. So there's was it supposed to be if else?
Okay.
I don't know. Does there need to be another if statement or something?
Yeah, maybe. Okay. Uh, yeah, else over here. Maybe.
Yeah, I could see that. Are we talking about syntax or logic issues right now? Oh, sorry, I was just sending an email.
Um, not actually sure. So it's this like ill-formed if statement is what it's saying.
Hmm. Okay, I'll try and pull up the notes real fast. Do you guys, I mean, would we be able to just use a cond? Because cond is pretty easy.
Yeah, we can do that.
I think. I don't know. Wait. Uh, wait a second. Hold on. For your if there, you just
Mhm.
want the if to just immediately check base case and then return, right? So your if actually wraps around the entire logic loop. So you're saying if it's null, then return an empty list and then also check an equal and then else. So I think you
Okay.
make the F right there. Um, and then you would do another if here, and this would be a right. Yeah. And then I think you could even you might be able to remove the else there.
And then we need another parentheses, right?
Yes, as long as it's matched up. Why is there a parentheses around L2 for cons L2? I don't think we, because L2 is just a value, right? It's not a function. So I don't think we
Yeah.
need that. Oh, good. Car is good. That's a function. Union is good. CDR is good. Yep, L2 is fine. Okay, so you're saying
Let's just go for it and see what it says.
it looks good. Yeah, let's do it. Is that right?
Wrong number
Uh,
of arguments passed.
okay. I may need to start if it's 5 minutes. It may be a good idea for me to
Yeah.
like upload the
Mhm.
files.
I sent you a screenshot of output with two different test cases, Oliver, and then the scheme file itself.
Awesome.
I mean, it looked just like my brief inspection. We might have actually gotten it.
I mean,
Almost.
it had like a little error. I feel like if we had a little bit more time, we probably would have.
Yeah. Get the
Let
lab.
me just let's see if I can get this one done in 2 minutes.
Let's
It's not gonna
go.
happen. It's
I
not gonna
believe in you.
happen.
I
Oh
believe.
my gosh. Oh, my windows are screwing me up the most, aren't they?
Oh God.
Okay, so we need to remove, create the function item. So we could just do a find function and then,
It returns a list. Okay. Okay. I don't even know. You want a car and CDR. You want a car first?
Mhm. So first check if the value is equal, and if it is, then CDR the rest of it. Base case might be if we actually find it. No, we can't assume it's unique. Yeah, just
Wait,
go.
what? Okay.
Mhm.
Otherwise, my parentheses good.
Let me see, Carl. Yeah, they look.
There's I did one right there. Okay. Otherwise, oh God. Otherwise,
Otherwise, we would. Um, okay, so we say it's true. We do CDR cuts it out, but we would just do that anyways, though. So how do we?
I think now what we want to do is that's bad. Okay.
1 minute.
I can't even email it that fast. Oh my gosh.
All right, let's write something. Okay, so if we just say we return it, if not, then just okay. CDR again for the else, but maybe for the
We want to like append two things. For cons,
cons. Yeah, we can con.
I think cons
Whatever the name is.
are
Yeah.
one and remove item. No, CDR. No. Yeah.
Yeah, remove item
Remove
CDR.
item CDR
You need to pass in the atom again
L1.
though.
Oh
If you
yeah.
yeah, just say ATM, that should be sufficient. Yeah,
And
CDR
another.
L1. Honestly, just save the file and submit it. This is something.
Okay. Well, it needs to display something. Whatever.
I don't know if we have time. It sucks.
Yeah, I've 23 seconds left on my.
World record any percent submit the email.
I don't.
Let's go. Good time. He's insane. Yes, yes, yes.
Did
Oh,
it send something?
he's insane.
Okay.
Did it send? Did it?
It's so sad.
I did get it just now. However, I ran out of time.
Oh man, that's all
So
right.
it's I think I don't know why I didn't think of this, or we didn't think of this like before, but it might be like a good idea for like one or two of us to have the thing open the whole time to read the questions. Then whoever's submitting opens theirs, like when we're ready to submit. That way, have enough time to upload everything.
What do
If
you
we're
mean?
allowed to do that, I don't know, because
Oh, like you mean
that
just
might be
scatter
like
it?
using more time than we're allowed to.
I think so. Maybe what we could do then is just after whoever just took control and actually typed it and stuff, whoever has it in their directory, while the other two people are starting the next problem and starting to think about it, they already send out the email. So that way, like they kind of get a break from thinking and they can send stuff. I guess it's something we can do.
It's a good idea.
Whatever.
Okay. Well,
Hard lab. I mean, so
yeah,
which ones did we get submitted? We submitted 1 through 4 then, I
yeah, we
guess.
submitted 1 through 4. 4 was a little iffy, but 1 through 3 definitely were
Solid, yeah.
working. So I don't know. I can't imagine that many people did super hot on this lab, but
This was really hard. Yeah.
yeah.
I don't know
Honestly,
why I'm doing this right now.
it
Whatever.
wouldn't hurt to just attach it right after and be like, hey, you can watch in the recording. We literally, we're nearly done. That's so unfortunate. We just had 91 minutes. Yeah, come on, guys. That's tough.
Right. Well, I'll fill out the survey and submit recordings and everything.
All right. Sounds good.
All right, appreciate it, man.
Have a good week, guys.
Hey, to you guys. All right.
You
See you
too,
next.
guys. Peace out.
Peace.